Example 20. A reducing right angle bend lies in a horizontal plane. Water enters from the west with a velocity of 1.8 meters per second and a pressure of 27.6 kilopascals, and it leaves towards the north. The diameter at entrance is 550 mm and at exit is 500 mm. Neglecting any friction loss, find the magnitude and direction of the resultant force on the bend. So to help analyze the situation, let's have the figure. So water enters here at the rate of 1.8 meters per second with a pressure of 27.6 kilopascals, 550 mm diameter, and leaves towards the north with velocity to be determined 500 mm diameter. So these are the components of forces needed to hold the bend in place. So the resultant force on the bend would be opposite to that resultant of these two forces to hold the bend in place. So it should be expected down to the right if these directions are correct. So summation forces x equals q rho quantity v2x minus v1x. That's the equation. Where we have F1 minus Rx equals Q rho quantity V2x minus V1x. F1 is pressure at 1 area 1, pi over 27.6 kilopascals times pi over 4 or 0.25 pi diameter square. Then we multiply 1000 to convert F1 to newtons, 6557 newtons. Then Q times rho is area 0.25 pi, 0.55 square, velocity 1.8, density of water 1000 kg per cubic meter. So 427.65 kg per second. Then we can now compute Rx, 6557 F1 minus Rx equals 427.65, quantity V2x is 0 because it is upward, minus V1x 1.8. So solving for Rx is 7327 newtons leftward as indicated in the figure. Then for Ry, we need to compute V2 first. So we write energy equation between 1 and 2, neglecting head loss. But before that, let's solve for V2 by continuity. 550 square 1.8 equals 500 square times V2. So V sub 2 is 2.178 meters per second. So writing now energy equation, we have 1.8 square over 19.62 plus pressure 27.6 over 9.81, pressure head plus elevation head 0. The bend lies on the horizontal plane, so the datum is on the horizontal plane also through the center. Equals velocity head at point 2, 2.178 square over 19.62, pressure head P2 over gamma of water, elevation head 0, then head loss neglected. So pressure at 2 is equal to 26.85 kilopascals. F2 therefore is 26.85 times pi over 4 or 0.25 pi, diameter 0.5 square times 1000 to convert it to newtons. Pressure times area. Pressure at 2, area 2. So 5 to 72 newtons. Summation forces along y equals q rho quantity v2y minus v1y. Take note that v1y is 0, v2y is 2.178. So the equation is ry minus f2 minus 5 to 72 equals q rho 4 to 7.65, v2y 2.178, v1y 0. So ry can now be computed equal to 6203 newtons. Finally, the resultant is opposite to these components. So down to the right, r is square root of 7327 square plus 6203 square. So r is 9600 newtons. Down to the right, at theta x equals 40.25 degrees, where 40.25 degrees is arctan of ry 6203 over rx 7327, opposite respectively to these components. That's it for this problem.